Dr. San Andres, Dr. Childs, and our other friends at the Turbo Lab. So recently, New Way has been involved in some gas bearing developments. The idea here is to replace oil bearings in relatively large turbo equipment, and we've built some test equipment to develop those bearings. Right now we're not using it, and we'd like to make a gift of it to the Turbo Lab if the Turbo Lab's interested. So this video is meant to be a quick description of those items so that you know what's available. So starting here, you can see we've got a test rig. These are pedestals. So these pedestals receive a bearing cartridge kind of like this, and you'll see that in this pedestal we have 5-pad tilt bearings that are preloaded on this 100mm journal bearing. So this is what the bearing looks like. There's 5 of them, and this is a 100mm. So this motor is a 3600 RPM motor. It has a variable speed drive associated with it. It's for testing the lower critical speeds. This is an 18,000 RPM motor, which brings the 100mm up to a competitive speed range. It also comes with a VFD and an absorber. So you can see that these drives are also mounted on plastic intentionally to reduce noise for the sensors. These pedestals and these cartridges also receive bushing type bearings. So here's an example of a bushing bearing. You can see there's an ambient groove in the center here, and then 2 lands of air bushing 360 degrees without any kind of separation in them. So these bushing bearings fit into a cartridge assembly like you see here, and then this whole cartridge fits into these upright assemblies, and there's 5 of these. So there's 3 of these that you're not seeing right now. So again, these fit on the backs that we have. These caps go on top. You can see they're pinned, so they're very precise alignment on these precision bores, so they were pinned and bored. The other thing is that we can apply force to this. So if you want to load this, you have 3 pedestals. One where you're holding bearings that's holding the shaft, another one's got bearings holding the shaft, but the one in the center you can load. So this is another radial air bearing, and you'll see it fits against the cartridge. So we can get 500 pounds of radial load against the bushings or against the tilt pad bearings in order to test them under a loaded condition. Now there's some other cool things that are available. You can see here, for instance, we've got unbalanced weights. You can see how out of concentric that is. That's meant for spinning unbalanced between bearings and testing unbalanced loads at the first critical. So that would be like 2200 for the shaft that was of interest to us. But the idea is below 3000 RPMs, you can use these big unbalanced weights. You can see this unbalanced weight spinning between 2 sets of bearings or pads. Then here you can see how it is rattling the whole table by looking at the water. See, the water will settle out. Set it down, it'll start. So we've got a real good shake going on here. And then for really high speed unbalanced testing, we have an unbalanced assembly that bolts over the end of the shaft. Then you can adjust for much finer, smaller, unbalanced weights, but at much higher speed, say 14 or 16 or 17,000 RPMs. So other cool items that are available, this is a way of also loading bearings in between. So we can put that in between the pedestal and we load the shaft or bearings under test to try to understand loaded dampers and how they're reacting. And here you can see this equipment is set up on our T-slotted table. But over here, what we could send you are, we have 2 of these plates. One plate here, and there's another plate underneath of these other assemblies. But these have the bolt hole patterns for these stringbacks. So this strongback bolts up into the bottom of this, so it makes a very rigid axial base. And then we have the pedestals. So you can see the pedestal here mounts directly to holes that are already pre-fit here. So we also have drawings and solid models of all of these components for your ease of modification in the future. We use these legs and angles and blocks to create a base for it. So we get a rigid floor-mounted assembly that is a great base for doing this turbo research. So these are some of the tilt pad bearings we have available for you. You can see some of them have a steel backs. Some of them have steel backs and have been intentionally light-weighted to try to make them respond a little faster. We also have them in solid graphite and carbon. So you can see here where there's been contact in the center, because this bearing does not have the same bending stiffness as a steel bearing does, a la Wilkes. He's definitely correct. The bending stiffness of the pad can have a big effect on the performance of the pad bearing.